So, in this topic, mathematical methods and its applications, you have already studied various methods of ordinary differential equations and partial differential equations. Now, the next topic is Laplace transforms. In Laplace transform, first we will deal that what Laplace transform basically are and why they are important. In what way, what type of problems we can solve using Laplace transforms, and how can we solve, what are various properties of Laplace transforms, and what happens if we have a continuous functions in our some real problems, how can we solve those type of problem, we will see in this unit. So, first is introduction to Laplace transform. Now, why Laplace transforms? So, Laplace transform is an important tool to solve any nonlinear ODE or PD integral equations or difference equations. The solution of we already know that if you solve a ordinary differential equation or a partial differential equation, first we have to find the complementary function and then the particular integral. The sum of these two will give you the complete solution. While when we use Laplace transforms, we do not require to find out complementary function or particular integral, we can directly find out the solution of the given system. Okay. The next important point why we use Laplace transform is there are some equations which use continuous or impulsive forces. In many engineering problems we have we can encounter such type of problems. To solve such problems, usual techniques are not applicable or difficult to apply. So, we use Laplace transform to solve such type of problems. Now, what Laplace transforms are? Now, Laplace transform of function ft is defined as Laplace transform is simply given by Laplace transform of some function ft is nothing but 0 to infinity e की power minus pt ft dt. So, it holds for t greater than or equal to 0. Now, of course, we are integrating respect to t. So, whatever integral we will obtain from here will be function of p, and here p is a parameter. So, we are calling it is a some function of p, so we are calling it fp, capital Fp. Okay, we are calling it fp. It will be a function of p. Now, now next is inverse Laplace transform. Now, if Laplace transform of ft is fp, which is a function of p, then if this happens, then Laplace inverse of fp is nothing but ft. Laplace inverse ft is nothing but ft. Now, the first property of Laplace transform is Laplace transform is a linear operator. It satisfies a linearity property. Now, what linearity property is? Laplace transform of a ft plus b gt is nothing but a times Laplace of ft plus b times Laplace of gt, and the result hold for any a and b constants, for any constants a and b. Now, let us try to prove this result. Proof is very simple. As we already know that Laplace transform of ft is given by this expression. Similarly, the Laplace transform of some function gt will be nothing but 0 to infinity e की power minus pt gt dt. So Laplace transform of a ft plus b gt, where a b are any arbitrary constants. So, this is nothing but 0 to infinity. So, here function is a ft plus b gt. So, this will be given by e की power minus pt. So here we have a ft plus b gt dt. So, this is nothing but when we apply the property of integration, so it is nothing but a times 0 to infinity e की power minus pt ft dt plus b times 0 to infinity e की power minus pt gt dt. So this is nothing but Laplace of ft and this is nothing but Laplace of gt. So we have this linearity property that Laplace of a ft plus b gt is nothing but a times Laplace of ft plus b times Laplace of gt. Okay. Now the same holds for inverse Laplace transform also. Inverse Laplace transform is also satisfy linearity property. How? That we can easily derive. Because because Laplace inverse of this is by this result itself, because when we take Laplace inverse, so Laplace inverse of a times fp plus b times gp will be nothing but a ft plus b gt, where ft is nothing but Laplace inverse of fp and gt is nothing but Laplace inverse of gp. So we have this result, linearity property of inverse Laplace transforms. Now next is Laplace transform of some functions. Now first we will see how we find Laplace transform of some functions. Okay, we will try to see some properties of Laplace transforms. Then we will see how we can solve a given differential equation using Laplace transforms by applying those properties which we will study. Okay. Now first is, let us find Laplace transform of 1. So how we will find Laplace transform of 1? So Laplace transform of 1 is nothing but, you apply the definition. What is Laplace transform of ft? Laplace transform of ft is nothing but 0 to infinity e ki power minus pt ft dt, what we have studied. So Laplace transform of 1 is nothing but 1 into e ki power minus pt into dt, because here function whose Laplace is to find is 1, is unity. So Laplace transform of 1 is nothing but 0 to infinity 1 into e ki power minus pt dt. So it is nothing but, what is the integration of e ki power minus pt? It is e ki power minus pt into upon minus p. It is from 0 to infinity. So it is minus 1 by p. Upper limit minus lower limit will give value as this. So it is nothing but 1 by p. So provided p is positive, so we are assuming p greater than 0. P greater than 0, then only the limit of this quantity will tends to 0 as t tends to infinity. Okay. So so Laplace of 1 is 1 by p. Okay, it's Laplace of 1 is 1 by p. So hence we can also say from here that Laplace inverse of 1 by p is nothing but 1, because if Laplace of ft is say fp, so Laplace inverse of fp is nothing but ft. So Laplace inverse of 1 by p is nothing but 1, by the same logic, by the same concept. Okay. Now now let us find Laplace of e ki power at. So again we apply the definition of Laplace transform. Laplace of ft is nothing but 0 to infinity ft e ki power minus pt dt. So it is nothing but 0 to infinity e ki power at e ki power minus pt dt. It is nothing but 0 to infinity e ki power minus p minus a times t into dt. We integrate it, so it is nothing but minus p minus a times t upon minus p minus a, 0 to infinity. So again, in order that this limit exists, this integral have some value, this must tend to 0 as t tends to infinity. So we assume that p minus a is positive, because then only e ki power negative quantity will tends to 0 when t tends to infinity. Okay. So we assume that p greater than a. So it is nothing but 1 upon p minus a. So Laplace transform of Laplace transform of e की power at is nothing but 1 upon p minus a. Okay. So again if Laplace transform of e की power at is 1 upon p minus a, so Laplace inverse of 1 upon p minus a is nothing but e की power at. Okay. Now let us try to find out Laplace transform of some function. So let us try to find out Laplace transform of 1 plus 2 into e की power 3t. So we know that Laplace satisfy linearity property. So by the linearity property we can simply say that Laplace of ft plus a times gt is nothing but Laplace transform of ft plus a times Laplace transform of gt. Now Laplace transform of 1 which we have already derived is 1 by p. So it is nothing but 1 by p plus. Now what is Laplace transform of e की power 3t? Is nothing but 1 upon p minus 3. So it is 2 into 1 upon p minus 3. So this will be 1 upon p plus, we can take LCM and simplify. So we can get Laplace transform of the first problem 1 plus 2 e की power 3t. Now we have second problem. Laplace transform of ft is to find out where ft is nothing but t when 0 less than equals to t less than equals to 1. It is 1 when 1 less than equals to t less than equals to 2 and 0 when t greater than 2. So for this function we have to find Laplace transform of ft. So what this ft is, if we visualize graphically, so from 0 to 1, suppose this is 1, from 0 to 1 ft is t, that is the straight line, that is a straight line, and from 1 to 2 it is 1, from 1 to 2 it is 1, this is 1, and after 2 it is 0, after 2 it is 0, at 2 it is 1, and after 2 it is 0. So this, so basically this is ft, this is ft. So we have to find out Laplace of this ft. So it is clear that this function is discontinuous at t equal to 2, because from the left side the value is 1 and while from the right side the value is 0. However, its Laplace transform is this, we can find out using the same definition. So Laplace transform ft will be nothing but 0 to infinity e की power minus pt ft dt. So it is nothing but from 0 to 1 it is t into e की power minus pt, because 0 to 1 ft is t, it is in the definition, 0 to 1 ft is t. So 0 to 1 ft is t, and 1 to 2 ft is 1 into e की power minus pt, and from 2 to infinity it is 0. Yes, from 2 to infinity is it is 0. So what will be the Laplace transform of this function ft? So this will be nothing but, now we can simplify it. So Laplace transform ft will be nothing but, now to integrate this this part, the first part, we will use integration by parts. Okay. So when you use integration by part, we will get t into e की power minus pt upon minus p minus e की power minus pt upon minus p square from 0 to 1. Then plus, you can use integration by parts here to simplify this expression. Now plus it is e की power minus pt from 1 to 2, so it is e की power minus pt upon minus p from 1 to 2, and rest is 0. So no need to find out the third expression, rest is 0. Now here we will get when t is 1, it is e की power minus p upon minus p minus e की power minus p upon p square. When t is 0, this is 0. When t is 0, it is minus minus plus 1 upon p square. Okay, yes, and it is nothing but plus e की power minus 2p upon minus p, and at 1 minus minus plus e की power minus p upon p. Okay. So we simplify it, so these two ratios cancels out, we simplify it and we will get the Laplace transform of the required function f t. Okay. Now let us try to find out Laplace transform of t, the third function, Laplace transform of t. Okay. So Laplace transform of 1 is 1 by p, Laplace transform of e की power at is 1 upon p minus a. Now let us see what is the Laplace transform of function t. So it is nothing but, again apply definition of Laplace transform, 0 to infinity t into e की power minus pt dt. So it is nothing but, again you will apply integration by parts. So when you apply integration by part, it is nothing but t into e की power minus pt upon minus p from 0 to infinity, and then negative integration 0 to infinity, derivative of first, integration of second. So at infinity, to see the value of this expression, we will simply find limit at t tending to infinity of t into e की power minus pt, and at t equal to 0 the value is of course 0 because of this expression t. So when you put t equal to 0, this is value is 0, minus minus plus, it is 1 by p. The integration of this is e की power minus pt upon minus p again from 0 to infinity. So it is minus 1 by p limit t tending to infinity t upon e की power pt minus 1 by p square. So we assume that p is positive, p is greater than 0. Okay, we assume that p is greater than 0. So p is greater than 0, this value will tend to 0 as t tend to infinity again. So it is 0 minus 1, and as t tend to infinity, this is infinity upon infinity form because p is positive. So we can apply a L'Hospital rule to simplify this expression to find this limit. So this is minus 1 by p. When we apply a L'Hospital rule, it is nothing but derivative of the numerator 1, derivative of denominator is p e की power pt minus minus plus 1 by p square. So when t tend to infinity, this is infinity and this value tend to 0. So minus 1 by p into 0 plus 1 by p square. So this is nothing but 1 by p square. So the Laplace transform of t is nothing but 1 by p square. Okay. In this expression, to find this Laplace of f t equal to t, we assume that p is greater than 0. So what will be Laplace inverse of 1 by p square? Laplace inverse of 1 by p square is nothing but 1 by t. Oh, t. Because Laplace of t is 1 by p square. So Laplace inverse of 1 by p square will be nothing but t. Okay. Now suppose we want to find out Laplace of t plus 2t plus 3 e की power minus 6t. So again we can use linearity property of Laplace transform. So by the linearity property, Laplace of this ft will be nothing but 2 times Laplace of t plus 3 times Laplace of e की power minus 6t. So it is nothing but 2 upon p square plus 3 upon p plus 6. So this will be the Laplace of this function. Now let us find Laplace inverse of this function. So Laplace inverse of this function. So what is fp here for this problem? For this problem the function of p is p plus 2 upon p minus 1 into p minus 2. We have to find the Laplace transform of this function. So first we will use partial fractions. So what it will be? It is nothing but equal to a upon p minus 1 plus b upon p minus 2. So we can find a and b by comparing the coefficient from both the sides. So here p plus 2 will be nothing but a into p minus 2 plus b into p minus 1. So a plus b is 1. The coefficient of p here is a, here is b. The total coefficient of p from the right hand side is a plus b, and in the left hand side is 1. So a plus b is 1, and comparing the constants, it is minus 2a minus b is equals to 2. So when you find a and b from these two, so minus a will be 3 when you add these two, so implies a is minus 3, and when you put a equals to minus 3, so b will be nothing but 4. So this expression is nothing but minus 3 upon p minus 1 plus 4 upon p minus 2. So this is fp. So what will be ft? Ft will be Laplace inverse of fp. Laplace inverse of this is to find out. So Laplace inverse of this we are calling as ft. So Laplace inverse of fp, which is equal to this and this is equal to this. So this is nothing but minus 3 upon p minus 1 plus 4 upon p minus 2. So this is nothing but minus 3 times Laplace inverse of 1 upon p minus 1 plus 4 times Laplace inverse of 1 upon p minus 2. This is again by the linearity property. By the linearity property of inverse Laplace transforms, we can write ft as minus 3 times Laplace inverse of 1 upon p minus 1 and 4 times Laplace inverse of 1 upon p minus 2. So what is Laplace inverse of 1 upon p minus 1? It is nothing but e की power t, because we know that Laplace inverse of 1 upon p minus a is nothing but e की power at. This we have already discussed. So here a is 1. So Laplace inverse of 1 upon p minus 1 will be e की power t plus 4 times. Again for the second term a is 2. So the Laplace inverse of 1 upon p minus 2 is e की power 2t. So this will be the Laplace inverse of this problem. So this is the answer. Now suppose we want to find out Laplace inverse of p plus 4 upon p into p minus 6, some expression of this type. So again we will make use of partial fractions. So what is p plus 4 upon p into p minus 6? It is nothing but a upon p plus b upon p minus 6. So what will be a and b? You can use you can compare coefficients from both the sides. So a will be nothing but, when you compare the coefficients, so it is p plus 4 will be equals to a times p minus 6 plus b times p. So 4 is nothing but minus 6a, so this implies a is minus 2 by 3, and the coefficient of p from both the sides is, here it is 1 and here it is a plus b, so this implies b is nothing but 1 minus a and a is minus 2 by 3, so it is 1 plus 2 by 3, that is 5 by 3, that is 5 by 3. So this ratio is nothing but a is minus 2 by 3 times p plus b is 5 by 3, so 5 by 3 times 1 upon p minus 6. So the Laplace inverse of p plus 4 upon p into p minus 6 is nothing but Laplace inverse of minus 2 by 3p plus 5 by 3 times p minus 6, because this expression is equal to this expression. So again, by the linearity property of inverse Laplace transforms, this is nothing but minus 2 by 3 Laplace inverse of 1 by p plus 5 by 3 Laplace inverse of 1 upon p minus 6. So this is nothing but minus 2 by 3. So Laplace inverse of 1 by p is 1. So into 1 plus 5 by 3 Laplace inverse of 1 upon p minus 6 is e की power 60. So this will be so this is equals to minus 2 plus 5 e की power 60 upon 3. So this will be the Laplace transform of Laplace inverse of this expression. So in this lecture we have seen that first of all, what is significance of Laplace transforms. The basic definition of Laplace transform is Laplace transform any function is simply 0 to infinity e की power minus pt f t dt, that we have already seen. Laplace and its inverse both satisfy linearity property, and we have also seen that Laplace transform 1 is 1 by p, that we have discussed. Laplace transform e की power at is 1 upon p minus a, and Laplace transform t is 1 upon p square. Okay. So rest we will discuss in the next class, that what are the Laplace transform of some standard functions.